Moving to the 40th question. In the above problem, given that M2 is double and M2 moves vertically downwards. Okay, with some acceleration A, position of the masses reverse, the acceleration of the M2 is. So let us once again draw the picture carefully because the masses are being interchanged. So the picture may be something like this. Here is your pulley. Two blocks of masses are being attached. This might be M1 and here it is M2. They both are attached to the pulley with the help of a string. Okay, but what they have given is M2 is 2m1 and if the position of the masses are reversed, the acceleration of M2 down the inclined plane is. So clearly the masses are reversed. Earlier example, what we observed was here M1 was there, here M2 was there. But in this example, the masses are reversed. Then this will become M2 and this will become M1. Is that clear? So masses are reversed. Earlier here M1 was there and here M2. Now the masses are reversed. Okay. So the acceleration of the M2 down the inclined plane is down the inclined plane. This is some acceleration. Okay. So clearly it was given that this is accelerating downwards. Okay. M2 moves vertically downwards in this direction. Hence this will be moving upwards. This is your case. Is that clear, children? Position of the masses are reversed and the acceleration of M2 down the inclined plane will be. So let us go with the equation part. So in order to find the equation part, first of all this will be your M2G. Here it would be theta and here it is M2G cos theta and here it is M2G sin theta. These are the things. Well, if you observe this, here it will be M1G and here it will be tension T, here also tension T. So again, let us go with the equations of motion. First of all, go with the equation of motion for this. As it is accelerating upwards, equation of motion can be written as T minus M1G equals to M1A. If you observe this, as it is accelerated downwards, downward force is more, that is M2G sin theta minus T equals to M2A. So solve the two things, children. While solving the two equations, we have T and minus T will get cancelled. Then you are left with M2G minus M1. This is M2G sin theta minus M1G is equals to M1 plus M2 into A. This is M2G positive value I wrote first and negative value I wrote second equal to M1A plus M2A. Take out A as common, then you are left with M1 plus M2. So acceleration A is found to be M2G sin theta minus M1G whole upon M1 plus M. Okay, or the value of A can be written as, given that the value of M2 how much? 2M1. So instead of M2 I can replace it with 2M1. G sin theta is sin 30 degrees minus M1 G by M1 and M2 is again 2M1. So A is equals to 2 M1G into sin 30 is 1 by 2 minus M1G by 3. M1 plus 2M1 is 3M1. Okay. So while solving the above case, we have this 2 and this 2 gets cancelled. Then we are left with M1G minus M1G. What is the value of M1G minus M1G? 0. 0 upon anything is 0. Hence, is there an answer, children? So when the system is being interchanged, this mass is replaced with M1 instead of M1, M2 is taken, instead of M2, M1 is taken. When such interchanges are being brought, the acceleration of the system is again found to be 0. But here that 0 is not there in the answer. So let us go with the option number 4. That is none of the. Clear, children? So acceleration of the system, new acceleration of the system. You can take it as new acceleration of the system after interchanging was found to be 0. So because so here also I'll take it as A dash and A dash. Is that clear, children? Everything is being changed. Okay, positions are interchanged, even the masses are also changed. So children, as we have found the acceleration is 0. Okay, but what was the formula for acceleration? This again may help you. The new acceleration, when the system is interchanged like this, the new acceleration was found to be this formula. So when the acceleration of the system is changed because of the changes, interchanging of the masses, the tension in the system may also change. Let us try to find out the new tension. So new tension, we assumed it as some T dash. So either you take first equation or second equation, you get the value of T dash. So I hope the first equation would be easier. So finding out the tension T dash from the first equation. Let me write as it is. T dash minus M1G is equals to M1A dash. So this was the equation as it is. So in order to find out the value of T dash, I need to take this M1G other side. Then this will become M1G. Minus M1G will become plus M1G into M1A dash. Or T dash is equals to M1 into G plus, instead of A dash, may I substitute this formula? What was that, children? It is nothing but M2G sine theta minus M1G whole upon M1 plus M2. That's it. Okay, so this value is equals to this. So T dash is equals to, let me take the LCM of this, M1 times of, okay, here G is common, so let me take the G as common. Then you are left with, as G is taken common, 1 plus leftover term is M2G sine theta minus M1 whole upon M1 plus M2. Taking the LCM, we have T dash is equals to M1G. LCM 1 into M1 plus M2 is M1 plus M2 plus M2G sine theta minus M1 whole upon M1 plus M2. Okay, so clearly this minus M1 and plus M1 will get cancelled. Then you are left with what, children? T dash is equals to, this is M1G. In inner side you are left with M2 plus M2G sine theta. Why again G? No G must be there. Okay, already G is taken out. Yes, G is taken out, children. What is that? M1G. Okay, this is M2 and here it is M2 sine theta. So both cases M2 is there. So I have also considered M2 common. Then you are left with, this is 1 and this is sine theta. So 1 plus sine theta whole upon, denominator you have M1 plus M2. Let me write it properly, children. T dash is equals to M1 M2 into 1 plus sine theta whole upon M1 plus M2 into G. That's it. So this is the value for new tension. Here is the value of new acceleration and here is the new value of new tension. Similarly, if you go with the previous one, this is the value of old acceleration and here is the value of old tension. So old acceleration, new acceleration we found. New old tension and new tension also we found it. So let us keep it aside. Based on that, let us try to solve the remaining numerical sum. So what is the 41st question it was given, children? It was given that in the above problem, given that masses is M2 is double the first mass and the tension in the string is T. When is the tension in the string? The very first numerical. If the positions of the masses are reversed, the new tension in the string will be. So you need to compare the new tension with the old tension. Okay, well, first of all, case 1. Let us go with the case 1. Case 1 means everything regarding the old tension. So what was the formula for old tension, children? Formula for old tension is M1 M2 1 plus sine theta by M1 plus M2 into G. M1 M2 1 plus sine theta into G by M1 plus M2 was the formula for old tension. But in this case, what they gave is mass is considered as 2M1. When M2 is taken as 2M1, then the new tension, the tension will be M1 into 2M1 into 1 plus sine theta into G whole upon M1, and again take M2 as 2M1. So T will be equals to 2 times of M1 M2 1 plus sine theta into G by 3 M1. So 2 M1 M1, this is M1 square. So simplify this, one of the M1 will get cancelled. Then you are left with T is equals to 2 into the value of M1 was given as 10 kg. I hope you remember that. The value of M1 was given as 10 kg and M2 was given as 5 kg. So M1 10 kg into 1 plus sine 30 degrees is 1 by 2 into G, let us consider it as 10 whole upon 3. Then what is this total value? So T value was found to be T is equals to 2 into 10 into 3 by 2 into 10 whole upon 3. So this 3 gets cancelled and these 2 gets cancelled. Hence the old tension was found to be 10 into 10 is 100 newtons. Even though the masses were doubled, M2 is equals to taken as a twice of M1 and substituted, we got the value of T as 100 Newton. Okay, now you need to compare the same thing with the new tension. So let us try to find out the new tension as well. What was the formula for new tension, children? Just now we have calculated the formula for new tension is again the same as old tension, that is M1 M2 into 1 plus sine theta into G by M1 plus M2. M1 M2 into 1 plus sine theta into G by M1 plus M2. Actually, you here also will get the same result as 100 Newton because formula remains the same. Earlier formula M1 M2 1 plus sine theta G by M1 plus M2. Here also new tension is also the same formula, that is M1 M2 into 1 plus sine theta into G by M1 plus M2. Okay, but if you take again the value of M2 as 2M1 and substitute, you will get the same result as 100 Newton. So T dash is equals to M1 into 2M1 into 1 plus 1 by 2 into 10 upon M1 plus 2M1 is 3M1. Solve this, you get the result as this M1 gets cancelled. Therefore, the value of T dash is found to be M1 is 10 kgs into 2 into 3 by 2 into 10 whole upon 3. So, simplify this, 3 gets cancelled, 2 gets cancelled. The value of T dash is again 10 into 10 is 100 newtons. That's it. Well, so as the formula remains same, the tension also remains same. Therefore, the new tension T dash is equals to old tension T. So, third option must be true. So, T dash is equals to T. Okay, children. So, no need to solve that. Only comparing the formulas will give you the result. But I tried solving for you. Well, now moving through the next question. Again, 42. In the above problem, given that M1 equals to M2, that's it. Now, equal masses were given. What will be the acceleration of the system? So, acceleration of the system in the above problem is when the system is being interchanged. So, let us take the acceleration of the system. What is the acceleration of the system? A dash is equals to M2G sine theta minus M1G by M1 plus M2. So, based on that, let us try to find out the acceleration of the system. So, remember this formula, children, M2G sine theta minus M1G. So, now moving to the 42nd question. In the above problem, given that two masses are equal, and what will be the acceleration of the system? Above problem is the problem as it is given by the book. Okay, so what was the problem given by the book? The very first, this was the actual problem given by the publisher. Okay, so in this concept, when it is given, the formula for acceleration was found to be m2g minus m1g sine theta by m1 plus m2. So taking the formula as it is, let us check the relation. So what was the formula, children? We know that acceleration is equals to m2g minus m1g sine theta whole upon m1 plus m2. What was that, children? Equals to m2g minus m1 sine theta into g by m1 plus m2. So substituting these values, what is the given relation? Given that m1 is equals to m2. What is given? m1 equals to m2. Let us suppose this as some m. Let us assume this m1 values and m2 values as m. So substituting in the above equation, we have a is equals to, so instead of m, let us m2, I'll write it as m only. G minus, again m1 also replaced with m, g sine theta. Sine theta is nothing but sine 30 degrees whole upon m plus m, or a can be written as mg common. Mg common means 1 minus mg common means sine 30 is 1 by 2 whole upon 2m. So solving this, we have this m and m gets cancelled. So therefore the value of a is found to be this g into 1 minus 1 by 2 is 1 by 2 whole upon 2. Okay, or a is found to be g by 4. The value of g is 10 and by 4, this is nothing but 2.5 meter per second square. Hence the correct option must be option C, that is 2.5 meter per second square. That's it, children. Moving to the last numerical from this worksheet. In the above problem, given that m1 is equals to m2 equals to 5 kg and what is the tension in the string. So in the above problem is the problem as it is given. But whatever the case be, we know the formula for tension as T is equals to m1 m2 into 1 plus sine theta into g by m1 plus m2. What is the value of tension T, children? m1 m2 into 1 plus sine theta into g upon m1 plus m2. So substituting those values, let us try to find out the formula for tension. Into g whole upon m1 plus m2. So the T value is found to be, you're given the value, each value for m1 and m2 as 5 kg. So this will be 5 into 5, 1 plus sine 30 degrees is 1 by 2, g is 10 whole upon 5 plus 5. I substitute all the values, m1 and m2 each taken as 5, sine 30 degrees 1 by 2, g is 10. That's it. So T is equals to 5 into 5 into 3 by 2 into 10 whole upon 5 plus 5 is 10. So solving this 10 and this 10 gets cancelled. Then you are left with, how much is that, children? This is 5 into 5 is 25. 25 into 3 is 75. So 75 upon 2 will be your 37.5 Newton. Hence option A must be true. Okay, so right from the numerical, what was that? 38, 39, 40, 41, 42, 43. All the 7 numericals are based on the one and only one concept. Okay, this masses, this whatever is given, some interchanges are being made and some values are being changed. Based on that, we have to calculate the numericals accordingly. So all the problems are based on the same concept. Okay, so go through these problems once again, children. Okay, take a pause carefully in a slow motion. Try to solve all the above equations. Okay, what is the new tension, what is the old tension, what acceleration, what is the change in acceleration if the masses remain interchanged, what was the previous acceleration. Go through this properly and then we can go with the other numericals. Okay, children, thank you. Keep practicing.